Imagine if the blueprint of your existence, your DNA, was not a biological miracle, but a complex code in a cosmic computer simulation. What if every trait, every decision, and every piece of who you are was programmed like lines of code in a vast, incomprehensible system? Here's the startling truth. Simulation theory argues that your DNA, the molecule at the core of life, might not just resemble a code, it could literally be one. DNA is often called the language of life, but it's more than just a poetic metaphor. It operates like a software program, complete with coding sequences, redundancy systems, and error-checking mechanisms. But here's where it gets truly mind-bending. Researchers have found patterns in DNA that resemble binary computer code, ones and zeros. This discovery raises the possibility that DNA could be evidence that we are living in a simulation, one designed with meticulous precision by an advanced intelligence. In this video, we'll uncover the secrets locked in your DNA and explore how it might prove simulation theory true. From scientific discoveries to philosophical implications, what you're about to learn will forever alter the way you see yourself and the world around you. And by the end, you'll be asking one question: if DNA is a program, who wrote the code? Simulation theory posits that our reality isn't physical but digital, constructed by an advanced civilization using technology far beyond our understanding. While the idea might sound like science fiction, mounting evidence suggests it's worth taking seriously. And at the center of this evidence lies DNA, a molecule so intricately designed that it has puzzled scientists and philosophers for generations. DNA is the fundamental building block of life, a sequence of nucleotides arranged in precise order to encode the instructions for every living organism. But why does it look so much like a computer program? Scientists like Dr. Craig Venter, one of the pioneers of human genome sequencing, have referred to DNA as the software of life. It contains coding regions, error-correcting systems, and even junk sequences reminiscent of unused lines of code in a software program. Even more astonishingly, DNA operates on principles similar to binary code, the language of computers. Instead of ones and zeros, it uses 4 nucleotide bases, A, T, C, G, in a structured, logical manner. This similarity has led some to speculate. Could DNA be the key to proving simulation theory? Could it reveal that our reality isn't random but intentionally programmed? The implications of this idea are profound. If DNA is a code, it suggests a coder. And if there's a coder, it suggests a purpose behind our existence. But before we dive into the philosophical side, let's examine the challenges and mysteries surrounding DNA as evidence of a simulated reality. The idea that DNA is a program brings up some difficult questions. First, why does DNA behave so much like a software system? While scientists have long marveled at its complexity, they've also struggled to explain certain anomalies. For example, DNA's ability to self-replicate and correct errors is astonishingly efficient, almost too perfect to be a product of random evolution. These features resemble the sophisticated algorithms found in advanced computing systems. Another mystery lies in junk DNA. Over 98% of our genetic material doesn't code for proteins, leading some to dismiss it as evolutionary leftovers. But what if this junk is actually dormant code, waiting to be activated? Could it hold instructions for future events, or even remnants of previous versions of the simulation? The biggest challenge, however, is philosophical. If DNA is a program, who wrote it? Simulation theory suggests that our reality could be the work of advanced beings running a complex simulation. But this idea raises existential questions. Are we just characters in a grand experiment? Do we have free will, or are we following pre-written scripts embedded in our DNA? These challenges are both thrilling and unsettling, and as we'll see in the next section, they're just the tip of the iceberg. What if we could prove that DNA is a code, and what would that mean for our understanding of reality? To understand how DNA might prove simulation theory, we need to delve into its uncanny resemblance to computer code. In 2013, theoretical physicist James Gates made a groundbreaking discovery. He found error-correcting codes embedded in the equations of supersymmetry, the laws that govern the universe. These codes are similar to those used in browsers to detect and fix errors during data transmission. If the universe itself operates on code, DNA could be the ultimate program within the system. Let's break it down. DNA's sequences are arranged in precise patterns that dictate how proteins are built. This process is so systematic that it mirrors the way a computer executes commands. Additionally, scientists have found mathematical patterns in DNA that resemble fractals, structures that repeat at every scale, often seen in computer graphics. These patterns are too structured to be random, suggesting intentional design. But here's where it gets even more intriguing. Researchers have experimented with storing digital data in DNA. In 2017, a team encoded an entire operating system and a movie into DNA molecules. This experiment demonstrated that DNA isn't just like a computer program. It is one capable of storing vast amounts of information in an incredibly efficient format. What does this mean for simulation theory? If we can encode data into DNA, it's plausible that an advanced intelligence could have encoded our very existence into this molecule. And if DNA is a program, it suggests that reality itself is a carefully constructed simulation. But how do we reconcile this with our sense of free will and individuality? That's the question we'll tackle next. Here's the breakthrough. DNA's complexity isn't just evidence of design. It could be the source code of the simulation. Imagine this. If DNA contains not only the instructions for life, but also hidden layers of information, it might explain phenomena like intuition, creativity, and even the human soul. These could be higher-level programs embedded within the code. This theory gains support from quantum biology, a field that studies how quantum mechanics influences biological processes. Quantum effects observed in DNA suggest that it might operate on principles beyond classical physics, principles that align with how simulations could work at a fundamental level. But the most compelling evidence lies in DNA's adaptability. Epigenetics, the study of how environmental factors influence gene expression, reveals that DNA can respond to external inputs in real time. This adaptability mirrors how characters in a simulation respond to changes in their programming. Could this be proof that we're living in a dynamic, evolving system? The implications are staggering. If DNA is a program, it suggests that the simulation is far more sophisticated than we can imagine. It also raises questions about the purpose of our existence. Are we here to evolve, to learn, or to fulfill some grand design? While we may not have all the answers, one thing is clear. DNA is more than a molecule. It's a gateway to understanding the simulation itself. Throughout this journey, we've explored the idea that DNA might prove simulation theory. From its resemblance to computer code to its adaptability and quantum properties, DNA challenges our understanding of reality. It suggests that life isn't a random occurrence, but a carefully programmed system. If this is true, it changes everything. Our sense of individuality, our understanding of time, and even our purpose in the universe come into question. But it also opens up new possibilities. If DNA is a program, we might one day learn to rewrite it, to unlock hidden layers of reality and discover our true potential. But the mystery doesn't end here. DNA is just one piece of the puzzle. What other clues might the simulation hold? And how can we begin to decode them? These are the questions that will shape the next chapter of our exploration. What do you think? Is DNA the ultimate proof that we're living in a simulation, or is it simply a biological marvel? Share your thoughts in the comments below. We'd love to hear your perspective. If you enjoyed this deep dive into simulation theory, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an upload. And if you're ready for more mind-bending ideas, check out our other videos. Thank you for watching.